everybody's installed Refind, we will continue with Secure Boot. I will ask the first question and you can ask the rest. Does anyone use Secure Boot? Oh. Under Arca? Is it on a separate computer? Or are you using dual boot or multi-boot or what?
It's a non-Windows machine. They are
Separate? Separate, okay. You two, separate machine?
No, but I'm not sure if it's activated or not.
Okay, Secure Boot. I hope I can enlighten you a little bit. I hope I'm not going to scare you. And I'm being serious. Secure Boot, behind the curtain. What is Secure Boot? Well, basically, Secure Boot is a security standard developed by members of the PC community to make sure that a PC should boot only software that is trusted. Sounds perfect, doesn't it? The question is, how do you do it? Now, normally, this sort of thing, you might think, will restrict your freedom, or some people will think it is preventing the installation of other software, of alternative systems, Arca OS for example, or using drivers that you need for a particular thing to do to have a particular mouse or disk or what have you, drivers that are not normally available under the operating system. The reason is that they want to make sure that you're not going to be vulnerable to attack on the firmware. That is what Secure Boot is trying to prevent. Yeah, this is what they say. The basis of Secure Boot is basically to have a database in the PC which will verify the integrity of the firmware and the bootloader. That's what they say. You're never sure what is marketing and what is real information in this respect. Why Secure Boot? During the boot process, the system is most vulnerable. You don't have any virus scanners operative at that moment. So what you're booting hasn't been checked. It can be easily compromised by so-called rootkits or bootkits injecting malware into your system. During booting, as I said, there is no antivirus software running. Malware can even get in and cloak itself in such a fashion that even when the virus scanner starts, it won't be found. Okay, that's the theory. How does it work? Secure Boot uses digital signatures. So everything that is booted basically has a signature, and that's checked by checking that the signature is valid. The signatures of the software are a set of trusted digital keys stored in the UEFI firmware. Trust and authenticity within Secure Boot relies on a public key infrastructure. This structure establishes a certificate management system which stores digital certificates. These certificates include those made by the original equipment manufacturer, the OEMs, and their representatives, and Microsoft. Microsoft having the big finger in the pie here. The idea is to generate key pairs that serve as the foundation of trust in the system. Yes. So when a PC first starts, the first thing it does is to verify that its firmware is digitally signed and valid. Next, the bootloader that is used to load the OS is checked that it is signed and trusted. Sounds great. What can go wrong? Then the kernel is loaded and its digital signature is verified. This is the case of Windows. How is the verification done? It is done by checking the keys stored on your PC in the NVMe RAM to match the digital signatures of the software. This sounds really great. So, as we said, when the PC starts, it verifies the firmware, the bootloader has a trusted certificate, the kernel has a digital signature, and that everything is done by the NVMe RAM. Well, that is where the public and private keys are used in this process. All secure boot keys use the public key infrastructure. Keys are created using the SHA-256 algorithm, and we all know since yesterday what SHA-256 is. Each key has two long numbers that are used for encryption and in the case of secure boot for data authentication. Secure boot uses a private key and a public key. This is a fairly standard method of control. Yes?
For some people, to make the comparison simpler, this is effectively the same thing that happens in your web browser.
Yes.
You've got a certificate from GoDaddy or something like that. Somebody issues a certificate from GoDaddy, and then the browser says, hey, this is a certificate that was made by GoDaddy.
Yeah.
And that's what basically happens
Yeah.
in your PC. With
Yes,
loaded
this
devices.
system is not new in that respect. It is used in other parts of software. The private key is used to sign the file, which is an EFI program, and that signature is appended to the program itself. So it's part and parcel of the file. That's where it's stored.
But it also gets a checksum, so that when it gets altered, that it...
Yes, that's true. The public key in the secure boot is embedded in the firmware. So when something is loaded, the public key is used with the private key to make sure it is valid. In order to verify signature, as I said, you have two pieces of data. You have an original message and the public key. The hash is calculated to make sure what we're doing, and the signature key is decoded using the public key and compared against the hash. This is approximately what's happening. You don't have to understand the details, you just have to understand the idea behind it, that you're cross-checking what is being loaded with a public key and a private key. If and only if they are okay, it will go further. The signatures are in fact embedded in the executables themselves. within each header in the EFI executable, there's an array with directory entries. And the fifth entry are your certificates. This is the details, just for your information. Keys have an hierarchy. You have the platform key, the key exchange key, and what you will see here is two databases. Oh, sorry, there are three databases, in fact. You have the allowed signature database and a disallowed database. It sounds a little bit strange, but what the idea was, we sign stuff, but maybe later on, we find it's not good. So we put in a disallowed database that key. So first, is it allowed, and has it not been disallowed? And there is the key enrollment database. Linux uses an extra database. It does it slightly different than Windows. It uses the MOK, or machine owner keys, that can create and sign components. But that's, as I said earlier, with Secure Boot, Linux uses a shim as a go-between between the EFI BIOS and the grub bootloader. This is the way it works. You have a platform key, which is determined by the OEM manufacturer and is used to sign any updates to the key exchange database. And as I said, there are two main databases involved, the allowed and the disallowed signature database. BIOS in itself does little to protect or prevent infection by pre-boot malware. The purpose of Secure Boot is to provide or add a layer of protection. When Secure Boot is activated, then and only when does the firmware check for encryption signatures. All UEFI systems have these signatures. The disallowed database, in fact, is a list of blacklisted items. So the validation is done by using public keys and checking the results using those two databases. As I said, check first with the allowed and the forbidden. Okay, you've probably heard of TPM. Everybody heard of TPM? Good. Trusted Platform Management. But it is required by Secure Boot. Secure Boot only works with UEFI. It does not implicitly require TPM. Officially, Windows 11 requires TPM. I have a system here, Windows 11. It shouldn't work or shouldn't have been updated, but it has been by the Windows Update system. You may wonder, do I have a TPM? You're still wondering, Roderick?
Most modern systems have one.
But what is TPM? It is either a physical embedded microcontroller, or it is in the microprocessor itself. That I didn't know. I always thought it was separate, but it's also in a lot of microprocessors. You might wonder, yeah, do I have a TPM? Under Windows, you can use the Win key plus R and type in tpm.msc. It will tell you then if you do or do not have a TPM. As I said, some processors contain a TPM. All the 8th generation Intel processors do. The AMD Ryzen processors from the 1st generation Ryzen 1000 series also do. And of course the newer ones. So you probably have TPM although you didn't even know it. Unless you have a really old system. In fact, most systems built during the last 15 years already have TPM technology. As I said, do I have TPM? You can do it in Linux by using the following command to read the sys class, TPM, so on. So you can check under Linux. In Windows, the command prompt TPM MSC. You get this sort of screen, and it will tell you TPM is ready for use. Under Arca, we don't have anything for it, correct?
There's nothing for it. No.
There's nothing for it. Now the fun bit. All certificates from Microsoft will expire in 2026.
You mean those are embedded in the firmware?
Yeah, they're all going to expire. So what happens? That, gentlemen, is the big question. What's going to happen? The database update will follow, this is according to Microsoft, the rollout process to reach all Windows customers during April 2024. So it's probably already happened. It has not been activated. I'm just letting that sink in for a minute. What do you think is going to happen? The Microsoft KEC CA201 11 is set to expire in 26. And all OEMs must create and sign an update. So what's happening to your KEC keys in your system? Are you going to have a BIOS update for this? I don't know. Nobody really seems to know what's going to happen. And this is a big worry. One of the problems is, if you think about it, that there's going to be a vast number of keys added to the disallowed database. The database updates, they're not static. They're happening all the time via Windows Update. As I said, this is happening during the standard update cycle. So if you log into Windows, it's happening. Linux has a similar update, but via another channel. Okay. One of the worries about the updates is the fact that the database size on your motherboard has never been specified. This means maybe the update to your disallowed keys database is not big enough. What happens then? Nobody knows. The problem with Secure Boot is that it was a sort of add-on feature put into UEFI, and a little thing like the size of the database was not specified. And we all know if it's not specified, it could be anything. And depending when the machine was made, maybe the NVMe RAM is bigger or smaller, we don't know. Yep.
In general, but this is generally speaking, it's either 32 or 64 kilobytes. And if you take into account that an SSL cert that's used can be a few hundred bytes, you can do the math that if those things need to be blacklisted to get those, and that for all the vendors, then you're quickly going to run out of gas.
Exactly.
It's already, I think about 24 kilobytes now, so
Yeah. And you saw the list that's going to be done, and it's not yet been activated, it's already been loaded into your system if you use Windows. So the big question is then, should you or should you not use Secure Boot? What does Secure Boot bring you? It should bring you security. It should bring you peace of mind. The last, I surely think it doesn't. One of the things that has been discovered is Black Lotus, to make you even more worried. What is Black Lotus? It's a boot kit. It is specifically designed to attack the UEFI and Secure Boot. I don't want to go into how it works, but it basically bypasses Secure Boot defenses. Yes?
If you want to talk about bypassing security, because I've been looking at Secure Boot for a longer time, what is already history, but a couple of years ago, Microsoft actually accidentally, in a toolkit, released the root certificate with which they signed the drivers.
Yes.
Oops. So there you can already see that by human intervention, they can blow the whole system. Because that meant that everybody could start publishing signed Microsoft allowed UEFI loaders with the Microsoft cert. They had put it in some kind of development toolkit.
Yeah.
Of course, that was a big embarrassment. There's also recently, there's a new one to make everybody more worried, that's even more interesting. This isn't Black Lotus, they discovered something else. And this is going to require a lot of laptops to be updated. Inside of the UEFI firmware is a library that allows you to display the boot logo of the vendor. Now here's the trick that somebody found out. The library that they used is filled with buffer overflows. And what you can do is you can put a picture with a lethal payload on the ESP partition, and here's the rotten part. That file gets loaded without looking at the cert. So now vendors have been running around over the last couple of months figuring out that they've used a library to show your boot logo of Dell, but now they found out that for PNG, JPEG, and a whole bunch of other file formats, there's a buffer overflow. So now they need to start patching all UEFI firmwares because that file that's on the ESP disk doesn't get checked. So there's another backdoor in UEFI, just to spice things up for you.
Yeah.
Thank you for your time.
The Black Lotus boot kit.
I know.
Yes, I know. Well, the Black Lotus specifically attacks the Microsoft bootloaders. Yeah.
What I want to add is exactly
Wait.
Hang on.
Sorry, the microphone is moving towards you. I don't know if it's going to
At
make
the speed of light.
The disallowed key database is exactly for the use case when a private key leaks, then you add it there and basically you are safe then again.
Okay.
That's the idea. Yeah, you have mentioned the two databases, the DB and DBX,
Yeah.
and the DBX database is exactly for that use case. So
Okay.
you can revoke or disallow
Yes.
then any binary that was signed with that private key, and therefore malware that has been signed with the leaked private key,
Yeah.
will no longer be accepted with the.
That is the idea of
That's
the
the idea.
yeah.
It's the same as in the web browser where
Yeah.
you also can revoke certificates.
But as I was saying, the big problem is maybe we're going to have the problem that the database is not big enough,
Maybe,
and then in the disallowed are nearly all bootloaders from Windows 8. And I have no idea how many bootloaders Windows keeps making, but there are quite a few. It also includes bootloads up to on Windows 11 up to the 9th of May 2023. So it's a lot of stuff. And because of this, Microsoft will update the Revoke database with all these bootload signatures. And that is the problem. We don't know how many, we don't know if it'll fit. As I said, the question is, how many will be updated? There is no default size in the UEFI specifications. Microsoft approached this by trying to limit the number of loaders which will be disallowed to the architecture used. So instead of throwing all the bootloaders for all types of architecture, for example, if you have an x86 architecture, they will only specify those. There's also a so-called damage control that seems to be going to be implemented. It's called Code Integrate Boot Policy. Yeah, it's not really clear what that will do. And when you think about all of this, you start to say, what's next? Secure boot wasn't well thought through. But now we have Pluton.
Yes.
Qu'est-ce que c'est? Yeah, Pluton, we have Pluton. That solves everything, guys. Yeah, what is Pluton then? It's a separate chip on the same die as the CPU. It's a sort of TPM, but then separate on the CPU. The idea being you cannot get at it, but if you can't get at it, how can you use it? That's the problem with any interface. The interface is always the vulnerable point. So, Pluton is self-sufficient, so-called, and that means it's out of band. Whatever that may really mean, I don't know. And you get security updates via the cloud.
Oh, that's secure.
I'm only telling you what I read. Yes?
So using my doom and gloom brain, the next thing that's going to happen is that cloud account gets hacked. And don't tell me it won't happen, because recently Microsoft had made a big cluster F, accidentally a sysadmin that was working for the Azure cloud, the whole Microsoft Office 365 crap, they put about 35 terabytes of random customer data accidentally on a public SharePoint share. That was supposed to remain confidential, but somebody pressed the wrong button. So just wait until it happens. There was a couple of years ago, Microsoft got hacked because they were using security software from, I think, a company called Digital River. And the bad, you Glenn, I think, know what I'm referring to. There was a case where a interim student at the I think it was Digital River, the security company, and they made security products. And the website from which the updater gets the updates for signature database was accidentally added to the FTP account of an interim student, and hackers figured it out. So they were able to compromise the secure download web page and add malware in the trusted download page. And there you had it. So within no time, they were able to get all of the stuff downloaded and end up on very sensitive servers, including the Pentagon and everything you can think of, because it was all being downloaded from a trusted source. So next time you have a cloud service, think twice.
Yeah.
Wait.
Welcome to the doom and gloom meeting.
I told everybody that this would have a cliffhanger, but here you go.
Okay, so there's a recent Google incident where, and this happened within the last month, and was surprisingly not as well publicized outside the, I'll call it the geek press. An entire, a company's entire cloud instance was removed without backups. The company had maintained a tertiary third-party backup, and they were able to restore it from there. Now, this was not a hack. This was a Google accident. So the message, though, to those of us that are still in the commercial world and utilize cloud every day is, I would absolutely say never trust it.
Yeah.
And I would absolutely say begin considering a out-of-band backup that is completely disconnected from the environment, where you, if possible, you could.
Sorry.
restore.
Sorry if I interrupted you with blowing my nose, but that's probably the sound we're going to get later on. What's happening in this?
Look, we all know that we probably have most of our data stored with Google,
Yes.
or Microsoft,
Yes.
and some degree with Apple. So, you know, we've got 3 bullseyes where a hacker can aim at.
Yeah.
And you just have to compromise the right account. Or there are people that are sitting at Microsoft that can press buttons to do admin stuff. Once you penetrate that, you know, everybody, all the companies that I worked for have cloud access, their email, their files, their R&D stuff. So, you know, no, but I'm predicting in the next 5 years there will be a big hit when you turn on the news at 8 o'clock and that suddenly all data is out on the street.
Yeah.
I hope I'm wrong.
Probably by state actors like China or Russia, because China is taking out the main key of Microsoft, and also Russian hackers are there, and we know that Russia killed KSAT 2 hours or an hour before invading Ukraine, and of course just normal criminals might do it too, but it might be also really
That's me.
worldwide kind of attack on infrastructure.
Okay, I was talking about Pluton. Just for your info, Pluton is already on certain devices. It's on the Ryzen 6000 CPUs. It's also, interestingly enough, on Qualcomm Snapdragon It's in your phone. It's also been used, I forget exactly where, but I thought on some PlayStation type devices, and they've been using it for some time. So you say, I'm not going to use Secure Boot, right? That would seem the ideal solution. Problem is, if you're a Windows user, you've got a problem. For example, BitLocker requires TPM, which in fact TPM requires Secure Boot. So you can't encrypt your data. I'm wondering if this all goes wrong and you've encrypted your data, can you ever get it back again? There are loads of warnings about updates, and the first thing they say is get your BitLocker key, save it, decrypt, do an update, switch on, and encrypt again. It's worrying. Windows Hello also requires TPM. The Defender Guard system requires TPM. So if as a Windows user you just want to switch it off, you've got to consider what functions are left for you. Maybe use third-party encryption of your data. I don't know. But it's not a black and white solution. Or we should tell everybody, use Arca OS. Yes?
To add to the doom and gloom, Windows 11, after it's installed, you can turn off Secure Boot. In fact, there is a switch that you can start the installer to work around it, and then it will ignore the. But with Windows 12, it's rumored that Secure Boot, even for the home version, will be enabled by default.
Yes.
So the moment that you switch off Secure Boot, every time you will get the BitLocker screen asking you to enter your 30-number long recovery key. So
I've only got 26 letters.
Yeah.
No, but seriously.
It's being pushed harder and harder.
Yes, yes. And as I say, I automatically got Windows 10 to Windows 11 update. I thought, well, Windows 11 requires Secure Boot, and I don't have Secure Boot on, but it happened. So things are taken out of your control. That's the problem. So, yeah. That was my story about Secure Boot. Roderick will tell you how we can implement it in Arca. But I've given you here some references. So as the Hacker News. I think Glenn was talking about the problem by, who was it you said? Glenn, Google was it? Or yeah, okay.
Unrelated to Secure Boot.
Yeah, yeah, it's unrelated.
Yeah.
Well, I read recently, this was also very worrying, and there is a group of programmers, it's open source, and they are using, updating stuff with regards to accessing servers. One of the very small subroutines was found to have been manipulated, which basically had a back door. You've heard about it, Roderick? No. Okay. It's had a back door. And people were very worried because this is open source, which basically means that everybody's looking at everything. And this subroutine, the guy that had got in there for Linux was an accredited guy. So this goes back years. So this is really deep work to get in to Linux, and most servers, as you know, often running on Linux, and to be able to get in and log on to all Linux servers. And there was this backdoor in this subroutine which would be automatically compiled with the rest of that software update. So security is very worrying. Two people at once. Please, Roderick, first.
Well, a lot of people probably know the program CC Cleaner, which falls into the same category of all of these banana peel slips. The source code was somewhere, I think, possibly stored on a cloud account. And the problem was that somebody actually got access to the source code of CC Cleaner, the original repository, and inserted some malware.
Yeah.
And then the developers took the CC Cleaner, compiled the infected sources, so this wasn't an infected binary, they would just make changes in there, and then they distributed the CC Cleaner was distributed via the normal channels,
Yeah.
and then suddenly after a couple of days everybody went like, oops. But what happened basically, they were able to get in because they could hack the repository, just like with
Yeah.
the digital river or something that I just mentioned. So, you know, yeah, do you trust the stuff? You know, it's all out there, and they just need to find one backdoor, and your whole security
Yeah.
just disintegrates.
But
You had a question?
yeah.
Keith, have you been talking about server management firmware or just the Linux login process? Because stuff was inside a not very well designed compression software, and there these long-term backdoor got introduced, and the trick of it is because the Linux loader loads this stuff
No,
and it can change the login process even
Yeah.
if the login process itself is not compromised, but
No.
it is loaded by the kernel, these other things.
As far as I understood, this was an article in CT
Yes.
in last month, the Dutch version. So you can probably refer to it there, but the biggest worry was that apparently this was a long-term exploit planned long ago and very efficiently, and people don't think this was just done by a hacker.
And the guy who discovered it is a Microsoft developer. He wondered why, damn, my login used to be less than a tenth of a second or so, and now all my SSH logins took
Yeah.
more than half a second more. And
There's
then
something wrong.
he started finding out what has happened and which ways the other developers from the kernel and such were tricked to get
Yeah.
it into it.
Yeah.
And
Well,
fast
yeah.
updates kernels got infected with this backdoor,
Yeah,
and the other more long-term.
Well, what I was reading hadn't yet happened. One of the guys, one of the developers, happened to look at that small piece of code, which was a sort of a standard library, which you always used, and he suddenly found this purely by accident, thank God. So it's never been implemented. So in the Linux community, there was a big panic from where else could this sort of thing be done if you're always using standard libraries when you are making software. So, yeah. Anyway, that was the doom and gloom series. Are there any questions which I might or might not be able to answer? So the big question to you is, are you going to use Secure Boot? Are you forced to use Secure Boot? Do you have an alternative? I don't know.
Well, is gluten the alternative?
Sorry?
Isn't gluten the alternative?
It sounds more or less like the new version, new clothes, new improved. I don't know. What I read doesn't tell me much. It looks very much like a marketing story rather than the actual description. Sorry, guys. Yes, Roderick.
Well, one of the things that people also need to know about Secure Boot is that there are some low-end devices like Chrome notebooks and that have actually an Intel CPU in it. And for example, a Microsoft Surface tablet with an Intel CPU, you can't turn Secure Boot off. But, and here's the big but that I want to emphasize, there keep these conspiracy theories going around where people saying, oh, Secure Boot is going to be mandatory and it's not going to be possible to disable it. Here is my counter argument why that will not happen in the foreseeable future. And here the salvation people are Linux and FreeBSD. Because if you are a kernel developer, and it's only a minute group, but it exists, how can you compile a kernel if Secure Boot only allows you to load that kernel? In other words, what I'm saying, most high-end business laptops will probably, in the foreseeable future, continue to have an option to turn Secure Boot off. There are also some corporate tools that are not signed by Microsoft and are having their own AFI loader. So there will probably still be a way to turn off Secure Boot in the foreseeable future because there's a technical need for it and there's no easy way to replace it, I think.
Well, I agree. The reason for Secure Boot is obvious. And basically we need something like it. We only hope that we will get a system that really works and doesn't have all these pitfalls that we are currently experiencing. And I hope, for one, that the rollout of the blacklist database does not give the problems that it may appear to give. I hope it will be something like the year 2000 bug, which frightened everybody, but fortunately did not really happen. But, well, this is just conjecture, I don't know. I hope I have given you sufficient information to be aware of what's happening, to give you the information to say, do I or do I not use Secure Boot? And if you use it, what you have to be aware might happen. Thank you, gentlemen.